Alright, so my name is Calvin Dang, and I'll be going over my final project for artificial intelligence. I decided to do my own project, and it's particularly going to go over a BayesNet. So to begin, here is the BayesNet that I have. At the top, we have no gas in car, and engine is broken. The engine is broken is going to influence whether or not we will be able to go out this weekend. And then engine is broken, and no gas in car will go over whether or not our car will start. And then that can affect whether or not we miss class, and that affects whether or not we fail a test. So a lot of the code is going to be from homework 4, which was sort of influenced by the solutions from the BayesNet. So in order just to save time so that I can have more time to talk about the probabilities that I calculated below, I'm just going to go over this. There's notes in there and in homework 4. So we start by creating the particular BayesNet that we have right here. And then in order to make sure that all the code was correct and just to make sure that my math was correct, I wanted to calculate some of the probabilities by hand. So first I wanted to calculate what is the probability that our car will not start equals true. And then as a reminder, it is going to be this middle node right here. And then so in order to do that, we saw that it was influenced by it had two parent nodes that sort of influenced it. And that was going to be whether or not we have gas and whether or not our engine was broken. And in order to get that isolated probability right here, we're going to have to enumerate over all the possible states that the parents could be in, so true or false, gas or no gas, and engine broken or not broken. And then here's the equation for that. And then we have to sum over all of that to get the isolated probability of whether or not our car will not start. That results in 0.065. And then a similar process with whether or not we can afford to go out that weekend. And this one only has one parent node, so one item that influences it. So we only have to enumerate over one node as opposed to two, like above, and that gives us 0.411. Then as seen right here, get the same exact number, so the code is all good. And then for section 2, this is pretty much looking at or comparing different probabilities. So I'll start off by what is the probability that we miss class given that our engine is broken, and then what is the probability of me missing class given that my engine is broken and that my car has no gas. So if we go back up, looking at these particular nodes right here. And so if we go right down here, and then I do have an analysis that goes more in depth with the explanation, but in order to save time, I'm just going to go over a basic explanation right here. So we know that the probability of me missing class given that my engine is broken is going to be 0.503, and then if we add the additional knowledge of my car also not having gas, it's going to bump the probability of me missing class up to 0.744, and that's just due to the sort of effect that the engine being broken and the car not having gas. So if we likely do not have gas and our car is broken, then we are most likely to be in a state where our car does not start. And then in the BayesNet, the car does not start influences whether or not, or is the parent of whether or not we go to class. And so with additional knowledge of us not having gas, we know that it's more likely for a car to not start, and then we are more likely to miss class. And then for the second, I'm comparing the probability of my car not starting given that I miss class, so like the reverse of the above, and the probability that my car will not start given that I miss class and I fail a test. And then here we see that the probability is not affected. If we go back up, we are looking at the connection between car will not start, miss class, and failed test. So right here, we said the probability does not start, and that's because whether or not I fail a test and my car not starting, those two are going to be conditionally independent of each other given that I missed class. And that's just because the additional knowledge, as seen through the calculations of me failing a test, does not influence my belief on whether or not my car will start. And then here I have the definition of conditional probability or conditionally independent probabilities. And then right here, I just prove that they are equal just to show that they are conditionally independent of each other given misclassed. And then here I go a little deeper into the definition. So you can read that for more depth. And lastly, I'll be comparing about whether or not the probability that my engine is broken given that my car will not start, and then adding the knowledge of whether I do or do not have gas in my car. Just as a reminder, we're looking at these top 3 nodes right here, this little V shape. So hopping back down, initially, if we know that our car will not start, then the probability of our engine being broken is 0.19. Now, if we add the additional knowledge of we do have gas in the car, and just as a reminder, we know that whether or not we have gas in the car and whether or not our engine is broken is going to affect whether or not our car will start. And since we know that the car will not start, and we know that we do have gas in the car, then we're more likely to attribute the car not starting to the engine being broken. So that's why you see the probability right here jump up to 0.71. And then conversely, this is going to be if we do not have gas in the car. So if we know that our engine is broken, and we also know that the gas is not in the car, we're more likely to attribute the gas, not having gas in the car, to the car not starting as opposed to contributing it to the broken engine. So that's why our probability jumps all the way down to 0.02 right here. And this is going to be the common effect or a sort of diagnostic relationship between these. So if we know the status or the evidence of one of cars not starting's parent nodes, then the probability of that will affect the probability of whether or not our engine is broken.